Hello everyone, welcome to my channel. In various kinds of games, we may observe there is one specific type of class which automatically casts skills during normal attacks and inflict damage by those auto-casted skills, including but not limited to Autospell Shadow Shader in our most familiar Ragnarok Online. However, a natural question may arise. How do we calculate the DPS of such characters? This question can be super complex because the answer does not only depend on the gears and the stats of your characters, but also depend on the special mechanism of the skills that you triggered. Now, the Ragnarok calculator, which helps you determine the damage of each specific skills, is not able to derive your answer directly. Therefore, in this video, we are going to discuss how to do the computation. A video showing that a Shadow Shader beats Midnight Arena Fenrir will be attached at the last part of this video. For most of skills which is triggered at a fixed rate and deals just one bundle of damage, its contribution to the DPS is quite easy to compute. For each hit, there are just two sample points in sample space, whose sigma algebra identically elicit two events, trigger or not trigger. Since we know the probability measure of each event, we can easily use the basic integration to calculate the expected damage from each hit, multiply it by the times of hit per second, we can calculate its DPS. You may refer to my previous video for a mathematical definition of probability measure, sigma algebra, and the basic integration. However, some skills have a very specific mechanism which makes the computation harder. For example, Lord of Vermilion is a very popular skill for Shadow Shader since the Ring of Pazuzu can largely increase the damage of this skill. However, Lord of Vermilion has a protection time mechanism, that is, anything hit by this skill is temporarily immune to this skill in a certain period of time. I use two warlocks to make a verifying test and comparison and find out the protection time is exactly half second. This brings a problem. If two Lord of Vermilion is both triggered in a two subsequent time of normal hits, then the second one will be ineffective. Therefore, even though the Shadow Spell skill from Shadow Shader has a 15% of chance to automatically cast Lord of Vermilion, the effective trigger rate is actually less than this value. To figure out the effective trigger rate, we first formalize this question to facilitate our computation. In maximized attack speed, we deal 7 normal hits to the object per second. Therefore, if we imagine a scenario of sequential hits, a successful trigger of Lord of Vermilion will make any trigger in the following 3 hits ineffective. Only by the 5th hit can we consider the possibility of effective trigger again. Finally, it becomes a Markov process with memory. We define 4 states. S0. The skill can be cast effectively at a 15% trigger rate. S1. The object is just hit by the skill. Any trigger this time will be ineffective. S2. The object just experienced S1 and any trigger this time will be ineffective too. S3. The object just experienced S2 and any trigger this time will be ineffective too. And we know the following transferring rule. From S0, there is a 15% chance of transferring to S1, which means Lord of Vermilion is triggered, and 85% chance of staying at S0, which means it has not been triggered. From S1, it is sure to transfer to S2. From S2, it is sure to transfer to S3. From S3, it is sure to transfer to S0. We can now write down the state transition matrix by solving the stationary condition with Python code. Finally, we know that under the stationary distribution, the effective trigger rate for Lord of Vermilion is 10.34%. However, if we consider the skill of Tetra Vortex it will be more challenging. Even though that Tetra Vortex didn't have a protection time mechanism like Lord of Vermilion, it requires 4 elemental balls to be summoned for a successful cast of this skill. The autocast of Tetra Vortex comes from the equipment elemental set. Now we can have a look on its description. It has a 30% chance to cast Summon Fireball, Summon Water Ball, Summon Lightning Ball, and Summon Stone individually. And it has another 30% chance to cast Tetra Vortex. According to my in-game test, I found it that the event of summoning each kind of elemental ball is actually mutually independent with each other. Moreover, during each normal attack, it first calculates the possibility of summoning elemental balls and then calculate the possibility of triggering Tetra Vortex. For example, if before the normal attack I have summoned 3 elemental balls, it is possible for me to successfully cast the Tetra Vortex if during this normal attack I have summoned 1 more elemental ball and trigger Tetra Vortex in this normal attack. After a successful cast of Tetra Vortex, the amount of elemental balls summoned before next normal hit will always be clear to 0. Also, we should be careful about 2 concepts, Tetra Vortex triggered and successfully cast. When Tetra Vortex is triggered, but we don't have 4 or more elemental balls summoned, the Tetra Vortex cannot be cast successfully. And we will also maintain the amount of elemental balls we have summoned. Only when we have enough elemental balls summoned, a trigger of Tetra Vortex can turn into a successfully cast. In order to compute the effective trigger rate of Tetra Vortex, we have to define 5 different states. S0, S1, S2, S3 represents the current amount of summoned elemental balls before the hit is 0, 1, 2, 3 respectively. And S4 plus means that currently we have 4 or more elemental balls summoned before the hit. As we know, each hit has independent chances of activating the 4 elemental balls summoning event, each with 30% probability, and the Tetra Vortex trigger event also with probability 30%. We can then write down its state transition rules. From S0 to S0 has 2 different cases. The first is no summoning elemental ball event has ever occurred. The second case is pretty rare. It means all the 4 summoning elemental ball event has occurred, and the Tetra Vortex is also triggered. As to the transition from S0 to S1, S2, S3, S4 plus, it depends on how many summoning elemental ball events has occurred. Therefore, we could compute the transition probability of each different case. Similarly, we could compute the transition probability for S1, S2, S3, and S4 plus, and then use Python to solve the stationary distribution. Finally, we know that on the stationary distribution, the effective rate of triggering and successfully cast a Tetra Vortex should be 16.55. Now, after we make clear about those special mechanisms, we can combine them with the result from Ragnarok calculator to compute the DPS of a shadow shader. Thank you for watching this video. I hope it will be helpful to you. The last part of this video shows how I use the Abyss shader to fight against Midnight Arena Fenrir.